Alright, hello, sorry about that. I was trying to start the stream. Okay, can everyone hear me? Can everyone hear me? Alright, very good, very good. Okay, let's start, let's get going. Okay, let's not waste any time. So today we will be doing this set 1. Okay, so you should already have your trial revision set already. Yeah, just in case there are any non-students here, I believe you can go to the description in this video, the description under the video, and then you will see the Google Drive link there. Okay, you can go to the Google Drive link and then you go and download the this worksheet lah. Yeah, go and download this paper if you need. All right, but other than that, okay, any questions you have, you just write in the chat. Medical is holiday today. Yeah lah, you holiday, your junior need to have trials, you know. You think everyone also holiday like you yeah, my ex-student, your senior already finished SPM already on. Okay, right, so let's have a look. Okay, so this is question number 1, right? Question number 1 is temperature question. It's a heat question. Okay, every time you start a question, you must get into the correct mindset first, meaning you need to know what is the topic about. Okay, so once you know what's the topic, then you need to switch your head so that you go into the topic, you focus on the topic only. Okay, so diagram 2.1 shows a student taking the reading of a thermometer at 3 different positions, P, Q, R. Okay, this is a thermometer. Name the physical quantity being measured by the thermometer. Okay, so basically they're asking you, what does a thermometer measure? Yeah, so a thermometer measures temperature. Okay, so you just write the thermometer measures temperature. Okay, temperature. Next, state the definition of the answer, meaning what's the definition of temperature? Now temperature is actually telling us how hot is something. Okay, so the degree of hotness. Now we don't say how hot and how cold, because why? Cold doesn't exist one. Okay, in this world, cold is actually just a word that means less hot only. Okay, so cold isn't a real thing. You cannot transfer coldness one. Okay, so we say degree of hotness. Okay, you can transfer hotness, that's heat, but you cannot transfer coldness. Okay, so we call that degree of hotness. Next one. Okay, if I'm going too fast, you let me know. Let's say you don't have enough time, but actually if you don't have enough time to copy the answer, right, you can later on get the answers also in the link. Yeah, in the description, right, there's a link for the answers also. Okay, then you can refer back to there if let's say you cannot copy in time lah. Okay. Next one, what is the type of physical quantity you name in A1? Tick the correct answer in the box provided. Okay, temperature is something that has amount but doesn't have direction. Okay, temperature got no direction one. Yeah, so we call that a scalar quantity. Vector quantity means it will have direction. Next one. What is the sensitivity of the thermometer in diagram 2.1? Okay, sensitivity. This one quite common. This thing they will ask. Sensitivity means what is the smallest number? What is the smallest difference that you can detect? So if you look at this thermometer, that's 28. This is 29. So very obvious, the middle here will be 28.1, 28.2, 28.3, 0.4, 0.5, and so on. So the smallest difference that you can measure will be 0.1. Okay. Now normally our thermometer, right, will be in degrees Celsius. Okay. Normally our thermometer is in degrees Celsius. Yeah. So we don't use Kelvin, even though that's a SI unit. We are referring to the thermometer here. Okay. 0.1 degrees Celsius. Next, tick the correct position to take reading of thermometer. This one everyone should know lah. Okay, this one I think I don't have to explain much. So you always look at it from like horizontally. Okay, perpendicular to the scale. Yeah, this is the scale. You look at it perpendicular to the scale. Okay, next one. What is the reading of the thermometer based on your position in 2D? Okay, so we are seeing this line. Okay, so this is 28.1, 2, 3, 4, 5, 6, 7. So 28.7. Again, degrees Celsius. Yeah, degrees Celsius. Name a type of error due to the wrong positioning of ice during scale reading. If you read any scale, okay, you using the wrong position, we call that parallax error. Okay, parallax error means when you read the reading of a scale, you read wrongly. Okay, parallax error. Give 2 reasons why mercury is used in the thermometer. Okay, so in a thermometer, we have 2 kinds of liquids that are the most common lah. Okay, 2 kinds of liquids that are the most common. The first one is mercury, and the second one is alcohol. Okay, for both of these, right, you need to know what are the advantages and what are the disadvantages. Okay, yeah. So for let's say alcohol, alcohol advantage is alcohol can measure very low temperature because it doesn't freeze easily. The freezing point of alcohol is very low. Okay, so alcohol can measure low temperature. Alcohol is safe, not poisonous. Okay, so that's another reason why we can use alcohol. Okay, now for mercury, mercury can measure higher temperature. Because higher temperature alcohol will boil. So mercury won't boil. Okay, you can say high boiling point. Oops. high boiling point, okay, can measure higher temperature. Okay, another advantage is that mercury is a very good heat conductor. Okay, compared to alcohol, mercury can conduct heat better, which means it can actually reach the temperature faster. Like it can show temperature faster. Yeah, so you put it in hot water, very fast, it will show you, oh, this is the temperature. For alcohol, it might take a longer time because it's not a very good conductor. Okay, so you say good heat conductor, more sensitive to heat. Okay, more sensitive to heat. Alright, next, name one principle involved for the measuring of thermometer. Okay, so for thermometer, how does it work or why does it work? It's because the liquid inside the thermometer becomes the same temperature as the thing that is measuring. Yeah, so you put it in, you make it touch something hot, then the liquid inside will also become hot. That's why it will expand and move. Okay, so this is called thermal equilibrium. Okay, thermal equilibrium. Alright. Next, based on the answer in G1, explain how thermometer measures temperature of hot water. So now we're gonna explain why is it like that lah. Okay, so you can say when thermometer is in thermal contact with the hot water. Okay, this is the first thing. Thermal contact means that it must be able to transfer heat between each other. Okay, must be able to transfer heat between each other, right? Okay, then you say net heat flow. Why net heat flow? Why don't just say heat flow? Because actually the hot water transfers heat to the thermometer. The thermometer also will transfer heat to the hot water one at the same time. Okay, at the same time. So if you say heat flow from hot water to thermometer only, then it's wrong, because heat will also flow from thermometer to hot water. But when we say net heat flow means the hot water transfer more heat to thermometer. Thermometer transfer very little heat to hot water. After you minus everything, okay, after you contra everything, only the hot water will transfer heat to the thermometer. Okay, that's the meaning of net. So net heat flows from high temperature hot water to lower temperature cold water. Cold water pula. It's a thermometer. I was thinking about the hot and the cold mix. Okay, from high temperature hot water to low temperature thermometer. Okay, yeah. Then thermal equilibrium is achieved when there is no net heat flow. Okay, you must mention thermal equilibrium will happen. Yeah, and then when thermal equilibrium happen, that means the temperature will be the same. Okay, temperature of thermometer will be same as hot water. Okay, thermometer, temperature of thermometer will be same as hot water. That's how my thermometer can measure the temperature of the hot water. Okay, a bit long, this answer. Yeah, a bit long. If you cannot copy finish, then never mind lah. Right? You just write down first what you can, and then later you refer back to the answer. Okay? Now, by the way, this set 1, there are 11 or 12 questions, I think. Let me see. 7, 8, 9, 11, 12, 13. There are 13 questions in this set 1, so we're not going to be able to do all the questions. Yeah, if there is any specific topics that you want me to do, right, you let me know. We can jump to that question first. Okay, we can see whether there is that topic in this set or not. Okay, yeah, any specific topic you want me to discuss, you let me know. Alright, in the chat. Okay, because we cannot finish everything one. So I'm just going to do as many as possible, but we can jump topic 1, no worry. Okay, state a way to increase the sensitivity of thermometer being made. Okay, a few ways to increase sensitivity of thermometer, right? You can use a thinner wall of the glass bulb, meaning this part. Oh, sorry, they didn't draw. This part here, down here, you can make the wall thinner so that it's easier for heat to transfer in and out. Okay, or another way is you can make this inside, this tube inside, we call capillary tube. We can make it thinner. Yeah, make it even thinner. So you say narrower capillary tube. Narrower capillary tube. Okay, if the capillary tube is narrower, right, the liquid will actually move more, even for a small change of temperature. Alright, so that is question 1. That is a heat related question. Okay, so let's move on to question number 2. And just by looking at this mirror, I can tell this is Form 4 chapter 6, light and optic, right? Okay, light and optics. So I have a mirror, a curved mirror actually, and it's forming an image. So name the light phenomenon involved. So mirror is supposed to do what? Mirror is supposed to reflect light. So the phenomenon is called reflection. Reflection of light. Okay, reflection. The type of mirror shown here is actually this kind, where it is actually curving outwards. Okay, this kind of safety mirror or a wide angle mirror is always this type, okay, which we call convex mirror. Okay, convex mirror. If it's curved inwards like that, then it's concave, because this is it's like a cave you can stay inside. Okay, so this one shooting out, this will be convex. And all these wide angle must be convex. Okay, so why? Because it provides wider field of view. Okay, meaning it provides a larger angle lah. Okay, field of view is basically the angle that you can see. Alright, next one. Complete the ray diagram to show the formation of the image. Okay, so ray diagram will be like this. Very standard one, the ray diagram for mirror. Okay, this is not for lens, for mirror. Lens is different one. Okay, lens you have to go through this part, center here. For mirror, the first ray will be go straight. Okay, go straight until the mirror, and then you have to reflect off the mirror, correct or not? You have to reflect off the mirror. How to know whether you reflect here, or you reflect here, or you reflect here, or you reflect here, or maybe here, or maybe here, or maybe here? How to know? You have to refer to the F, the focal point. So after you go straight, right, you have to draw a line that connects to the F, okay? But this line, I'm going to draw dotted line. Why? Because this is inside the mirror already. Your light cannot go inside the mirror one. Yeah, that doesn't make sense. Okay, it's a mirror, you have to reflect away. So I draw this using dotted line because it's a fake line. Okay, it's a fake line. And then, now I can tell, oh, actually my light will reflect this way, like that. Okay, so this is how I draw my first light ray. Yeah? Okay, my second light ray, you aim for the C. Okay, the C is basically the center of this circle. If you continue this mirror, it will become a circle eventually. The C is the center. And the special thing about the center, right, is if you aim for the center, you will always go back where you come from. Do you understand? Let's say this is a mirror, let's say this is a circle. If you shoot the center, right, it will 100% bounce back one. It will go here and then it will bounce back. You shoot through the middle, it will 100% bounce back. Okay, through the center again. So if I have a light ray that is aiming for the center, like that, aiming for the center, it will 100% bounce back. Okay, you see, it goes in and then it will bounce back the same way. Okay, now of course, again, same thing. In the mirror, I cannot draw full line. Inside the mirror, I must draw dotted line. Okay, so that's why just now I didn't draw the whole thing yet. Yeah, so you draw dotted line inside the mirror, and then you see where does it intersect. These two lines, where do they intersect? That is where the image is formed. Okay, over here, this is the image. Okay? Yeah, let me know if you got any questions about the drawing. I know some people they might have some questions about the drawing. Yeah, they might have some questions about the drawing for ray diagram. Okay, state the characteristics of image formed in diagram 3.2. Now for characteristics, we have three different things we can talk about. The first one is it real or is it virtual? Okay, is it real or is it virtual? Now, this one is virtual. How I know? Because the image is inside the mirror. Again, how can you go inside the mirror, right? The mirror is not supposed to have an inside. So if you appear inside the mirror, then it must be fake. So every morning you look at yourself in the mirror, the you inside the mirror is fake, is virtual. You are the real one. Okay? So we can say this is virtual. Okay? Next thing is you can talk about the direction. Is it facing the same direction as the object or not? If yes, then it is upright. If it's an upside down direction from the object, then we call that inverted. Okay, so this one both also pointing upwards. Okay, so we can say that it is upright. Upright. And the last one is the size. Now this one very obvious, it is smaller than the object, so we call it diminished. If it's bigger, we can say magnified. If it's the same size, then we can say same size. If you're not sure, you just take a ruler and then you measure the height. Okay, so this is diminished, smaller. Okay, so state one use of this mirror in daily life. So this kind of mirror, yeah, we see them in the car park. Okay, we see them sometimes on the road. Okay, that is used as a blind spot mirror in the car park or on the road, because you cannot see what is around the corner because there's a wall blocking you. Yeah, so let's say like that. Okay, you drive here, there's another car coming here, you cannot see each other because there's a wall blocking, so you must put one of this mirror here so everyone can see each other. Okay, we also find this in 99 Speed Mart, 7-Eleven, all this convenience store, because it is also as a security mirror. Okay, security mirror. So you can say blind spot mirror at sharp corners, okay, or parking areas. Or you could also say security mirror inside a supermarket. Okay, security mirror inside a supermarket. Next, what happens to the size of image if the object is placed nearer to the mirror? Okay, what happens if the object is placed nearer to the mirror? Now this one, of course you can draw the object here and then redraw the ray diagram. Sure, you can do that. Yeah, put the object nearer and then redraw. But I just want you to think very, very hard. In real life, you definitely seen this mirror before. Okay? And what happens if you walk closer to the mirror? Just think. You surely know this one, experienced before. As you walk closer to the mirror, the image of you will also get bigger and bigger and bigger and bigger. Correct or not? Yeah? It doesn't matter what mirror you use actually, the closer you walk, the bigger you're gonna get. Okay? So you can say the image size increases. Okay? Increases. This is very logical, you don't need to know physics to know this. Okay? It's just your logic only. Become goofy. You see those people, they do the mirror and then they use their finger to press the mirror. Yeah, you go and see I think some of you maybe see before. Yeah, they go and then they go press the mirror and then their face becomes like that. Okay, all right. So this is a light and optic question. Okay, light and optic. So now we go on to the third one. Third one, I see Geiger-Müller. I know this is radiation. Form 5, chapter 6. Yeah, radiation. You see before, right? The funny video. Okay, so here is a method to detect leakage of pipes lay underground. Okay, so our water pipes, they are all underground one. Yeah, and if let's say there is a leak or let's say it bursts, we have to find it very fast. Why? If you don't find it, then the ground will drop. Nowadays, very famous, right? A lot of these holes suddenly appear in the middle of the road, right? It's because of this water, when it hits the soil and all that, right? The soil will become soft and then the road will boom, drop down. Okay? So we have to detect the leaks very quickly. But we cannot just dig up everything. So we have to throw in some radioactive substance inside and then we check. Sodium 24, correct, yeah? Sodium 24. But you don't actually have to memorize it now, okay? Yeah, in case you're worried, you don't have to memorize the name of the isotope one. So we put in the radioactive thing inside the water and then we just scan and see which part got more radiation. Okay? So if you keep moving this way, you get 290, 295, 284, 372, 290, 217. Very obvious, right? Okay, compare all, you can see there's one that is a bit extra. Okay, first off, what is meant by radioisotope? Radioisotope means radioactive isotope. Okay, so we do two of them separately. Let's explain the first part first. Radioactive means what? Radioactive means unstable nucleus. Okay, unstable nucleus. That's the meaning of radioactive. Then what's the meaning of isotope? Isotope which has same proton number but different neutron or nuclear number. Neutron or nuclear number also same lah, right? Both make sense one. Both will be correct one. Okay? Yeah, so I just split into two words and then I explain both words one by one. Then you get the meaning of radioisotope already. Okay, so which one is the one that has sudden peak out of all this? Yeah, A, B, C, D, E, F. Which one is the one that has a sudden peak? 290, 295, 284, 290, 216, 222, but suddenly 370, 372. Right? It's D, yes, correct. It's D. Okay? Now you gotta explain why. You cannot just say D only. So you say the sudden increase. The sudden increase in reading. Okay, the sudden increase in reading shows that radioisotope is coming out from the leakage. Okay, the sudden increase in reading shows that radioisotope is coming out from the leakage. Okay? Alright, now we have a nuclide, thorium-234, placed in a container. It decays to a nuclide of radium-226 by emitting alpha and beta particles. So we know for sure this thing will emit alpha and beta. Now we are supposed to draw the path of alpha and beta particle. Okay, so this is an electric field. You can see the plus and minus here. So first of all, you need to know what is alpha and beta first. Alpha is 2 protons and 2 neutrons. Okay, beta is 0, -1. It's an electron. Okay, it's an electron. So alpha is positively charged, beta is negatively charged, which means alpha will be attracted to the negative plate and beta will be attracted to the positive plate. So you draw like this. Alpha, okay, or you can spell alpha, right, whichever one, okay, and then the other one, like that, beta. Okay, yeah. Now, why beta have to go up so quickly? Is because beta is much lighter. Okay, alpha is much more heavier than beta. So alpha is a bit slow to like pull over, but beta is very easy to pull over. Okay, now explain your answer, explain why they move like that. So you say, alpha is positively charged. Okay, positively charged and deflects to the negative plate. Okay, beta is negatively charged. Okay, beta is negatively charged and smaller mass. Okay, beta is negatively charged and smaller mass, so it deflects greatly to the positive plate. Okay, beta is negatively charged and smaller mass, so it deflects greatly to the positive plate. Makes sense, right? Yeah, makes sense, I mean, so far the question's not that hard, right? Okay, hopefully your trials also like that lah. Okay, hopefully your trials also you think, oh, so far the question's not that hard. Okay, calculate the number of alpha particle and beta particle that are emitted in the thorium after writing the decay equation. Okay, so the decay equation, you always write it like this. Now, you don't say thorium minus alpha and beta become radium, correct? In chemical equations, we don't have minus on ma. So what we do is we say thorium has decayed into radium, okay, plus how many alphas plus how many betas. Okay, so we write down the number for thorium and radium first, since they already gave us that. Okay, then we also write down the numbers for alpha and beta first. 4, 2, 0, -1. Make sure you remember this, Make sure you remember alpha is 4, 2, and then beta is 0, -1. Yeah, this is the chemical equation lah. This is the chemical equation. It's not fixed one, so you have to depend on what they give you. So since they say thorium become radium, okay, then we have to write as thorium become radium. Okay, sometimes there will be uranium becomes something. Then you have to follow uranium becomes something something plus alpha and plus beta. Okay, yeah. Alright, so now how do we check how many alphas and how many betas? We always start from the alpha first, because the top number is only affected by alpha, not affected by beta, because beta is 0 at the top. So no matter how many beta you release, doesn't affect the top number. Okay, so you check the top number. 234,226. You find the difference. 234 minus 226 is 8. Right? 8. So how many alpha must you release to lose 8 nucleon number? The answer has to be 2 alpha. Correct or not? Yeah? So 2 times 4 is 8 ma. So again, you check the top. It's actually simultaneous equation one, you know. Yeah, if you didn't notice, it's actually 2 simultaneous equation. So 234 is equals to 226 plus 8. So it's correct lah. That's correct. Okay, now you look at the bottom. 90 is equals to 88 plus 2 times 2 is 4 ma. But 88 plus 4 is what? 88 plus 4 is 92 already. 92. So you still have to do what? You still have to minus 2. Only you can balance both sides. Yeah, you must get both sides to the same number. So minus 2 means I need to release 2 beta, because this is 2 times -1. Okay, so that's how you write this formula. Okay, so it releases 2 alpha and 2 betas. Can Okay, now sometimes when you look at other books or what you might see them add another thing behind called energy. This one, if you forget to add, also never mind. Okay, it's not important one. It doesn't affect the equation. So even if you write or you don't write, it doesn't matter. Okay? Okay, next one. Thorium-234 has a half-life of 20 days and initial mass of 48 grams. Define the meaning of half-life and calculate the mass of undecayed thorium after 60 days. Okay, got 2 questions here. So we do the first part first. Define the meaning of half-life. So half-life is how long does it take for your radioactive thing to half. Okay, yeah, how long does it take for radioactive thing to half? So we say time taken for half of radioactive substance or radioactive nuclei or radioactive nucleus to decay. Nuclei is just the plural for nucleus only. Yeah, it's the plural for nucleus. So even if you don't know you don't know how to write nuclei, you write nucleus. Never mind, can. Correct. Okay, so time taken for half of radioactive nuclei to decay. Okay, so originally this thing got 48 grams. Okay, 60 days 60 days is equals to how many half-life? You can write down first. 60 days is equals to 3 half-life, because each half-life is 20 days. So 60 days is 3 half-life. Alright? So 48 gram, you half one time, you get 24. You half another time, you get 12. You half another time, you get 6. So this is 1, 2, 3 times you half already. So that's your answer. Okay? Mass of undecayed thorium is 6 grams. Just like that. You don't need any fancy calculation. You don't need to show your working or what. This is your working. You just show them that you half 3 times already. That's it. This is your working already. Okay, right? Now, for essay questions, I'm not gonna write down the answer lah. I'll just briefly go through the answer and tell you why. But later on, if you want to copy, again, just get the answer sheet. Yeah, this worksheet and the answer is in the link in the description down there. Okay, so you just click on the link, you can get the answers later. Okay, so you are trying to determine the most suitable radioisotope as a radiotherapy treatment. Okay, this one. Most suitable isotope for radiotherapy treatment for brain tumor. Okay, brain tumor. Now, this means what? This means that you're trying to treat a human. Okay, trying to treat a human. So, when you're trying to treat a human, you have to make sure that the half-life is short. Yeah, always you have to make sure the half-life is short. Okay, so half-life, I'm going to choose the 3 shortest half-life because there are 5 choices here. Let me just choose the 3 shortest one. 5 minutes, 6 hours and 7 hours. Okay, the days and years is considered too long already lah. Yeah, for a human, right? Because we don't want it to stay inside the body. That's the reason. Okay, the next one is the ionizing power. Ionizing power cannot be too high, because if it's too high, it will damage the other cells also. Yeah, it will damage the normal healthy cells. You are trying to kill the tumor cells only. So you cannot choose higher ionizing power. You must choose low ionizing power. Okay. Next one is the type of radiation. Now, if we are shooting this from the outside, which normally is what we do, when you have a tumor, right, we will take the radiation and we shoot it from the outside. And then we shoot it from all angles. We will shoot it around like that, keep turning it around, so that we keep on aiming the tumor, but then the other cells take turns. The other cells, they don't get so damaged because they are taking turns to get hit. But we keep aiming the tumor, so the tumor dies first. Okay? Since we're shooting it from the outside, yeah, normally we cannot use alpha because alpha will be blocked by our skin. So you gotta use gamma. Okay? Because it has the highest penetrating power. Beta, if you shoot through the skin, right, then it's not that strong already. It can still go through, but it won't be so strong anymore. Okay? So we gotta choose gamma, which has the highest penetrating power. Okay? And even if you put into your body, same thing also, because we want it to penetrate the cells. Yeah, we want it to penetrate the cells. Okay, and anything that's covering the cells. Yeah, so it must be either gamma or beta. Normally gamma lah. Okay, and the last one will be the state of matter. Now, state of matter, it will be liquid. Okay, it will be liquid, right? So we will do injection lah. No problem. You're welcome. Okay, we will do this by injecting the radioisotope into the body. That's why, again, the half-life short is very important. Okay, so here you can see 2 choices are acceptable, but we will go with the shortest half-life one. Okay, even though these 2 are both, they both hit all the criteria, but we will choose the shorter half-life because that will be safer lah. Okay, so you choose P. Alright? Okay, so later you want to copy, you refer back to the answers, okay, link in the description. Okay, let's look at question number 4. Question number 4 is, I think is electromagnetic induction, yeah, just from the apparatus here. Okay, so diagram 9.1 and 9.2 shows movement of identical bar magnets into solenoid, same force to produce current, both solenoids made of same wires, and then zero-centered galvanometer. Okay, underline the correct answer. The method of producing current without electricity, meaning when you make your own electricity, what is it called? It's called electromagnetic induction. Okay, when you make your own electricity, it's called electromagnetic induction. Okay, next, on diagram 9.1 and 9.2, state the polarity of region P. You know what's polarity or not? Polarity, North Pole, South Pole, that's polarity. So how to know what is the pole here? Now this is something called Lenz's law. Okay, so Lenz's law says that when you make electricity, when you do electromagnetic induction, the thing that you create, the electricity that you create, will always try to stop you. Okay, you see, if let's say I cover up this thing, this one got no electricity one, right? But when I have a magnet pushing down, you create electricity here. But this electricity will try to stop you. How to stop you? Oh, you're coming in, I have to make myself the same pole, because same pole will repel. You want to come in, I push you back, I stop you. If let's say you're trying to pull away, you try to pull this away, I will faster change to south, because I want to pull you back to stop you. Okay? So right now both of these will be north, because both are trying to come in and then I'm trying to stop him. Okay? So both are North Pole. North Pole. Oh, the law to determine, just now I said it is Lenz's law. Lenz's law. Alright, now we compare the number of turns of coil. Number of turns of coil, this one definitely more than this 9.1 more than 9.2. Of course, in your exam you write the full sentence. Number of coils in diagram 9.1 is more than diagram 9.2. Okay? Next is the deflection of the pointer here. This one. You can see from 0 in the middle, this one move a little bit only. But this one from 0 in the middle, this one move a lot. So again, 9.1 greater than 9.2. The deflection of the pointer in 9.1 is greater than 9.2. Okay, so what's the relationship between number of coil and the deflection? So since 9.1 got more and 9.1 is greater, we can say the more the number of coils, okay, the greater the deflection of the pointer of the galvanometer Okay, the greater the deflection of the pointer of galvanometer. Okay, then next question, you don't just read magnitude of induced current. Later you don't understand what's the question asking. It's the same question, D1 and D2. So state the relationship between number of coils and the magnitude of current, means how much current. Of course the current is this thing right? The more you deflect, the more current you have So you can just say the same thing. The more the coil, the more the number of coils, the greater the magnitude of induced current. Induced current means current that you make, current that you produce. Okay, next, state what will happen to the deflection of galvanometer if a stronger magnet is used. Stronger magnet will have what? Will have more what? Stronger magnet will actually have more magnetic field lines. Okay? Let's say normal magnet, the magnetic field lines look like that. Yeah. Okay? If you use stronger magnet, you get like that. Okay? So then you will have more cutting. This one cut 4 at the same time. This one cut 8 at the same time. Okay? So you're gonna produce more electricity one. Okay? You're gonna produce more. So what happens to the deflection? The deflection increases. Why? Because stronger magnets have more magnetic field lines. Okay, so more cutting of magnetic field lines produce greater current. Okay, more cutting of magnetic field line produce greater current. That's why the deflection increases. Okay, this physics principle is actually called Faraday's principle or Faraday's law. Basically, this person, he just said that, oh, if you cut more, you produce more electricity. If you increase the rate of cutting, you produce more electricity. Yeah, a bit bullshitting lah, a bit like just saying the obvious lah, but then yeah, he said it, so it's his law lah. Okay. Alright, next. This is a bicycle dynamo. Yeah, bicycle dynamo is the thing that you attach to the bicycle wheel. When you ride the bicycle, it will spin this dynamo and then it will produce light. I mean, not produce light in the dynamo lah. It will produce electricity and then the electricity will go to a light and then you can turn on the light. Yeah? So explain how the bicycle dynamo works. So you say, when the wheel or when the bicycle tire rotates, it rotates the coil of the dynamo. Okay? When the bicycle tire rotates, it rotates the coil of the dynamo. Now it doesn't matter who rotate one. Okay? Dynamo rotate also can, coil rotate also can. It doesn't really matter. So the magnetic field or the magnetic field lines are cut by the coil. Okay? The magnetic field lines are cut by the coil. Then you say electromagnetic induction. Electromagnetic induction occurs and current flows into the lamp. Okay? Every time you are doing explanation, every time they ask you to explain electromagnetic induction punya question, you must include a few words. you must include cut. Cut what? Cut magnetic field lines. Okay? And then you must have the word induction. If you don't write electromagnetic induction, you must say EMF is induced, or you must say induced current. Either you have this word or you have induced. Must have is a keyword. Okay, it's a keyword. So how do we increase the brightness of the bicycle lamp? You can have stronger magnet, or you can have more number of turns of coil. Okay, stronger magnet or more number of turns of coil. Now you don't say cycle faster, even though technically yes, if you cycle faster, you will get a brighter light. Technically yes, but you cannot say that because they are asking what can we change to the dynamo to make it brighter. Okay, not what can we do to the human cycling. Okay, so the next one, again, I'm just going to briefly discuss the answers. Later on, you just copy okay, from the answer sheet. So I want to make a moving coil ammeter that can function better. Function better probably means more sensitive, or it can bigger range, so on and so forth. Okay, so first of all, number of coils, more, so you can have more magnetic field strength. Okay, material of core, soft iron. Always use soft iron core because it can magnetize and demagnetize easily. Okay, shape of magnet, use a concave shape magnet or a curved magnet. Don't use straight one. Okay, yeah, so this can produce a radial magnetic field. Radial magnetic field is better than straight magnetic field because you will have a strong magnetic field no matter how you turn. That's the advantage of this radial magnetic field. Okay, low stiffness of spring, because if your spring is too strong, too stiff, the needle cannot move, the needle cannot deflect, so lower stiffness. Okay, and then how to get accurate reading, right? This one very special. You want to get more accurate reading, you put a mirror underneath. Okay, you see, this, let's say this is the number, right? 1 2 3 4 5, like that. You put a mirror strip here, okay, so that when you have a needle, right, if you look from the side, you will see two needles. You look from this side, you see two needles. Only when you look at it exactly downwards, you will only see one needle. So this is to avoid parallax error. Okay, you add a mirror under the pointer. Okay, yeah, later you can copy this from the answer sheet lah. Now I'm going to move on to question number 5. Okay, question number 5. So let me see, this I believe will be momentum, yeah, or inertia or something related lah. Okay, it's a force and motion question. So I have a car and a lorry stopping at a red traffic light. When the traffic light turns green, the car is found to move ahead of the lorry. Oh, I thought the car fly up. Okay, no, the car moved forward already. What is meant by velocity? Velocity is displacement over time. How to write this in English? Rate of change. This is divided by time. Okay? Rate of change of displacement. Very easy. Okay? Rate of change of displacement. If they ask you, what is meant by acceleration? Acceleration is velocity over time. So, rate of change of velocity. Just like that. Okay, compare the mass of the vehicles. So definitely lorry, should write mass of lorry lah. Mass of lorry is greater than mass of car. Okay, mass of lorry is greater than mass of car. The ability to speed ahead, of course, the car got more ability mah. So the car has more ability or greater ability to speed ahead than the lorry. Okay? Relate the mass of the vehicle and the way it can start moving from rest. So I answer the first part first. Relate the mass of the vehicle and the way it start moving from rest. So very logic. You want to say lower or greater, doesn't matter lah. Whichever one. You can say the greater the mass, the harder it is to start moving from rest. Okay? You can also say the lesser the mass or the lower the mass, the easier it is to start moving from rest. You can use that also. Doesn't have to always be one or the other. You can change. Okay? Alright, next. Define the physics. Oh, sorry, I haven't deduced the concept. Deduce the concept. You say this is known as inertia. Okay, this is known as inertia. Okay, so what actually is inertia? Inertia is the object wanting to stay doing what he's doing. Okay? The object, right? If it's not moving, it just wants to stay not moving. If it is moving, it just wants to stay moving. That's the meaning of inertia. So we call that a tendency. Yeah? Tendency means you always want to do this or not. Like if I say you have the tendency of being late, that means you always want to be late or not. Okay? You always become you are always late. You have the tendency to say bad words. That means you always say bad words. Okay? Yeah, so this is because of inertia, correct. So tendency of an object to remain stationary or moving in a straight line. Okay? Tendency of an object to remain stationary or moving in a straight line. Okay? So using this concept, using inertia, explain why the driver will fly forward if the car comes to a sudden halt, if the car suddenly stops. Okay? So we say before it stops first. Before it stops, what is it doing? Before it stops, the car moving ma. The driver also moving ma. Right? So you say, when the car moves or when the car is moving, the driver moves together. Okay? When the car is moving, the driver moves together. Yeah? So when the car suddenly stops, the inertia of the driver will do what? Because the driver was moving ma. Then the inertia will say keep moving, keep moving, keep moving, keep moving. So the inertia of the driver causes the driver to continue moving. Okay? Therefore, the driver lurches forward. Okay? You don't need to know what is lurch lah. But it means like that. That's lurch. Okay? You just copy lah. As long as you know forward means it will go in front ma, like that ma. So you don't need to know what is lurch also. Alright? Explain how you would escape from being chased by a bull based on the same concept. So if you get chased by a bull or an elephant or a hippopotamus, anything that's heavier than you, yeah, including if you get chased by your mom, as long as your mom is heavier than you, you can use this same idea. Okay? So you should run zigzag, or actually just run like it just run, you just suddenly change direction. Okay? Run in zigzag motion. Okay? Run in zigzag motion, or you can say change direction suddenly. Okay? Change direction suddenly. Yeah? So why? Because the bull has greater mass, or the bull has more mass than a human. Okay? This means what? This means the inertia of the bull is greater. Okay? So it is harder for the bull to change direction. Okay, it is harder for the bull to change direction. Understand? That's why it works on anything that's heavier than you, not just bull only. That's why I say even your mom also can. If let's say you get chased by your mom, but your mom is heavier than you, also can run. Right? As long as it's greater mass. Okay? Yeah? So this is an ordinary bicycle, and I want to do what? I want to ride the bicycle safely at higher speed. So it needs to be safer, it needs to be faster. Braking car produce a large backward momentum. Cannot. Because this is not about momentum one. When you brake the car, right, it doesn't produce backwards momentum. Something must move backwards, then only got backwards momentum. Yeah? So the thing must go in that direction, only can consider got momentum. So if the car brake, it's still going forwards ma. So it's not backwards momentum one. Yeah. Okay? Alright, so the bicycle, mass of bicycle always smaller mass, lower mass. Okay, so that it can accelerate faster, you can say. The material for bicycle must be low density. Low density material means it will be lighter weight. You could also say strong material, does not break easily. Also can. Okay? Width of tires, bigger width, greater width, wider. Okay? Wider is more stable. Yeah, wider is more stable. But if you are joining the competition, like the track cycling competition, yeah, like you know the one in Olympic, then our Malaysian cyclists, our only hope for gold medal got disqualified. That one, that track cycling, that one must be small weight, because that one they want to reduce the friction. Okay, but for us normal people, you want it to be safer, wider tire, so that it's more stable. Okay. The braking distance, type of braking distance. I think this is a type of brakes bar. You should change the type of brakes bar. Okay, so you can say stronger brakes, yeah, stronger brakes, or you can use hydraulic brakes. So you can stop the bicycle in shorter distance, yeah, shorter braking time. And then the attire or accessory. Attire, you can say tight attire to reduce air friction. Accessory, you can say wear helmet to protect the head. Okay? But you just need 5 only lah. You just need 5. So this one you just choose 1 only. Just choose 1 to write. Okay, can Okay, now this picture, once you see it, you should know this is what? This is Bernoulli's principle. Okay, Bernoulli's principle. Now, what does Bernoulli's principle say? Never mind, later we will talk about that. Okay, compare the airspeed at P and Q when I have air flowing like that, and if it goes into this tight little space here, it needs to go faster because everyone wants to squeeze through together. So you have to run faster in order for everybody to make it in time. Okay? Yeah? So whenever you have a tight space, it will be going faster. Just like if you take the hose, if you take the pipe and you cover half of the pipe, the water will start to come out faster. Okay? It's the same idea because it's a smaller space. So you can say airspeed at region P lower than region Q. Okay, Q is faster. Yeah, Q is faster. So according to Bernoulli's principle, right, if your speed is faster, your pressure becomes lower. Okay, so P higher pressure than Q. Okay, since P is lower speed, then P will be higher pressure than Q. So why is there a difference in water level? Because P higher pressure ma. High pressure push down more ma. This is low pressure ma. Low pressure push down a bit only ma. Right? So you say lo, you explain everything lo. According to Bernoulli's principle, okay, according to Bernoulli's principle, region with high airspeed, speeds have lower pressure and vice versa. Okay, region with high air speeds have lower pressure, and region with low airspeed have higher pressure. That's the meaning of vice versa lah. Okay. Alright. Next. What do we say? We say, okay, at P, airspeed is high and pressure, airspeed is lower at P. At P, airspeed is low and pressure is high. At Q, airspeed is high and pressure is low. Now, of course, you could also say this and this. Yeah, you could just write these two down also. Airspeed at P is lower than Q. Therefore, pressure at P is higher than Q. You can say like that also. Okay? So you say the difference in pressure, causes the difference in water level. Okay? The difference in pressure causes the difference in water level. Alright? Okay, now, how do we calculate the difference of water pressure? So we got to use the formula for water pressure, right? Formula for water pressure, P equals to H rho G. So since we only want to know the difference in the pressure, we can just use the difference in the height. Yeah? The difference in the height will give you the difference in water pressure one. So this is 5 centimeters, 0.05, of course, meters are, okay, I changed the meters are. Density, rho is 1000, G is of course 9.81, okay? So you can calculate this, you multiply this 3, wow. I just realized after so long, is this the first time we are doing a proper calculation question? Yes or? Oh yeah, this is the first time we're doing a proper calculation question, huh? Okay, so 0.05 times 1000 times 9.81, you should get, let me get my calculator out. 490.5. Okay, 490.5. Now, pressure units, pascals. Okay, next one. Suggest 2 ways by which the difference in water pressure can be increased. How can I make it more obvious change? Okay, so give reasons for your answer as well. So the first thing, definitely, the speed, right, of the air, I can just make it faster lah. Okay, if I make the speed of air faster, right, the difference between these two will actually be more also. Okay, the difference between the two will also be more. Alright, so you can say increase speed of airflow. Okay, this is to produce greater difference in pressure. I mean, of course, whatever you say, the goal is to produce greater difference in pressure also lah. No matter what, that's always the reason ma. Okay, if you want a difference in water pressure, you have to produce a greater difference in air pressure as well. Okay, yeah, you can say greater difference in air pressure. Okay, the other one is you can make this thing narrower lah. Same idea also. You make it even narrower, then it will actually move even faster. Okay, so you can say reduce diameter at Q. Okay, reduce diameter at Q. So you say to increase speed of air through Q. Okay, to further increase the speed of air through Q. Yeah. Now, if you wanna, you could also say reduce the diameter of this. The arms, okay? Reduce the diameter of the arms. Because when that becomes thinner, the level will become more obvious also one. Yeah, just like why when I make my thermometer tube thinner, it will be more sensitive. Same thing. If I make this arm thinner, it will become more sensitive to change. Yeah, more sensitive. Okay, what will happen to the water level if the non-uniform horizontal tube is replaced with uniform horizontal tube? Meaning, what will happen to the water level here if I change this to like that? Just everybody same size. Now, your first instinct might be to say, oh, then everybody will be the same lor, right? But actually no, it's not everybody will be the same. Okay, this side will now be lower. Because let's say you just make it all the same, right? Even though you think that the air pressure is same everywhere, it won't be. The air always go from high pressure to low pressure. Okay? The air always go from high pressure to low pressure. It's just that whenever you make this thing smaller, then you are making this super high pressure or super low pressure. Okay? You are making this super low pressure. Do you understand? So now, when you make it, wait, let me just look at this again. Airflow, high pressure, low pressure. High speed, low speed. High pressure, airflow from high to low speed, high pressure to low pressure. Hang on, just let me think about this first. There's a problem here. High pressure to low pressure. Yeah, no? Correct. Correct. Nothing wrong. Airflow from high pressure to low pressure. Yes. So this will be fast. This is super low pressure. Oh, then yeah. Actually, I think there will be no difference. There will be no difference because even if I remove this, right, it's still high and low. It's still high pressure and low pressure. So there will be no difference. But the water level won't be that much different. Okay, the water level maybe now will be like that and like that. Only small difference only. But it's still high and low. Yes, it's still high and low. It's still high pressure and low pressure. Okay, the difference is when there are 3 portions. Just now, yeah, that's why I was confused just now. Because if you have 3 portions, 3 portions like that. Okay, now, and then I make the center one narrower. I make it narrower. Okay, then this is what's gonna happen. High pressure, this is low pressure, and this is high pressure also. Correct or not? Yeah, you get high pressure, low pressure, high pressure. Okay, then your water level will be like this, like that, like that, like that. Okay, but if you compare these two, this will be lower pressure. This will be lower pressure, so this one will go up a little bit. Yeah, the air is not so high pressure here compared to the first one. Okay, but if you compare to the middle, definitely the middle will lose. The middle is surely the worst pressure, the lowest pressure, because the air is super fast here. Do you understand? That's why just now I was a bit confused because I was thinking about the three tubes one. Okay, but for this one, right, what's gonna happen is, even though they are straight, even though they are the same, okay, it's still high pressure to low pressure. Just that the difference now might not be so obvious anymore. Okay, the difference now might not be so obvious. So you can say the difference in water level, will be smaller. Okay, the difference in water level will be smaller. Yes. Okay, the next one. This is a lorry, and when the lorry travels at high speed, right, this piece of cloth or this cover, we call it the canopy. The canopy will boop, come out like this. Okay, so why? Explain why. Now the principle involved is definitely Bernoulli's principle. So the last sentence we definitely will write this is Bernoulli's principle. Okay, So you say, when the lorry moves at high speed, okay, when the lorry moves at high speed, what happened to the air? The air up there will be flying very fast, because the lorry moving forward, then the air will be moving very fast. But inside the lorry, the air is not doing anything. Inside the lorry, the air is not flying. Correct? The air is just staying there only. Okay? So, you say, the air above canopy is moving at high velocity. Okay, the air above the canopy is moving at high velocity. Yeah, then you say, this produces a region of low pressure. Okay, this produces a region of low pressure. Up here, high velocity means low pressure, So then you say, the higher pressure inside the canopy, the higher pressure inside canopy will push the canopy up. Okay? Yeah? Inside is higher pressure, outside lower pressure, so it will be pushing up. This is known as Bernoulli's principle. Okay? This is known as Bernoulli's principle. Okay, next thing, we have this Bunsen burner. So the melting point of the Bunsen burner definitely needs to be high melting point. Okay, density definitely needs to be low. Okay, sorry, just now I circled this one. This is not. So high melting point, low density. So doesn't melt easily, it is lighter. Low density always means lighter. Okay, now what else in front? We got small orifice and big orifice. Orifice means the hole. There is a hole on the side of the Bunsen burner that is to let oxygen come in. Okay? When the gas comes in through the nozzle, right, it will flow very fast, or we want it to flow very fast. So when it flows very fast, inside here will be high velocity, low pressure. Okay, inside here will be low pressure, which means outside pressure is higher. It will push oxygen into the hole and you will get complete combustion. Okay, you'll get a better fire. So we need to have a bigger orifice, a bigger hole for more oxygen, more air to come in. And the nozzle needs to be narrow nozzle, so that the gas can come in very fast. Okay, I want the gas to like be spraying out. Otherwise, if the gas doesn't spray out, then you don't get low pressure here. Do you understand? So we need to make sure that the gas sprays very quickly. Okay, yeah? So big orifice, narrow nozzle, high melting point, low density. Okay? Alright, next, let's look at, okay, let me see what's the time now. 11:30. 11:30, because I just want to cover a few things. Okay, I think I'm gonna stop here, and then I want to just cover a few things first, okay, just in case right? Few things that I think you should know. So okay, for the rest of the questions, you go through it yourself, and then you check the answers yourself. Okay? Yeah, the link again for this worksheet and for the answers, they are in the description below. So you get them yourself. Okay? So what I'm going to do is I am going to write some things down. Okay, okay, I just want to talk about a few topics here. So let's say I want to talk about oops, I think just now my internet went off a little bit. I'm back, right? Am I back? Am I still online? Just now my internet broke off a little bit. Am I back online again? Yes, can you all hear me? Yes, okay, alright. So, as I was saying, okay, I just want to go through a few topics here. Okay, the first thing that I want to talk about is interference. Interference of waves, okay? Now for interference of wave, right, you got to remember we have two kinds of interference. We have constructive interference and we have destructive interference. Okay, interference is when two waves they meet each other. Okay, two waves they meet each other and then they have constructive or destructive. So constructive, the meaning, if they ask you for the meaning, what is the meaning of constructive or what is the meaning of destructive? Okay, you say constructive is when the crest of one wave meets with the crest of another wave, or the throw of one wave meets with the throw of another wave. Okay, by the way, crest means the wave going up and then throw means the wave going down. Okay, and then for destructive, that means crest of one wave meets with the throw of another wave. Okay, so constructive, let's say they ask you to draw. They ask you to draw, that means you must draw like that. This plus this equals this, or this plus this equals this. They can ask you to draw, it's a very possible question. Okay, destructive is this plus this equals to this. Destroy. Okay, yeah, destroy. That's why called destructive. Okay, now under interference, there is another thing that they might ask you for the meaning, which is coherent sources. What's the meaning of coherent sources? So coherent source means both waves, okay, both waves have the same wavelength. You can either write same wavelength or frequency, it doesn't matter because they mean the same thing. And most importantly, right, you tell them this, they are in phase. Okay, in phase means they are the same timing. Both go up together, both go down together, both go up together, both go down together. That's the meaning of in phase. Yeah, so that's the meaning of coherent source. Coherent source. Okay, all right, so that's one thing. Now the next thing I'm going to talk about is Newton's universal law of gravitation. Newton's universal law of gravitation. Okay, so this law, right, states that F equals to G m over r squared. Okay, so the definition, you think of it like this. The definition got three separate parts. Okay, three separate parts. The first one is all objects in the universe, okay, all objects in the universe attract all other objects with a force. Okay, this part understandable, right? Everything in the universe will attract everything else. Okay, there is a gravitational force. Okay, now the second part, the force, okay, is directly proportional, perpendicular pula. The force is directly proportional to the product of their masses. What's the meaning of that? Okay, so we are saying that force, okay, is directly proportional to M1 and M2. Okay, force is directly proportional to M1 and M2. Let me just change this color. Okay, force is directly proportional to M1 and M2. This one, M1 times M2, the product of their masses. Okay, and inversely proportional to the square of the distance between their centers. Okay, so F is inversely proportional to the distance between their centers. Okay, yeah, so that's the third part. So three parts are: all objects in the universe attract all other objects with the force. Okay, part 2, the force is directly proportional to the product of the mass 1 times mass 2. Part 3, the force is inversely proportional to the square of the distance between the center. Okay, so remember, whenever you do calculation for the Newton's universal law, let's say there is one mass and there is another mass, M1, M2, the R must be the distance between the center. That's the R. Okay, R must be distance between the center. Okay, can Okay, next one. Radioactive decay, I already told you already, right? The definition of radioactive, haven't or? I told you the definition of half-life only. Okay, I haven't tell you what's the definition of radioactive decay. Okay, so the radioactive decay is spontaneous. Spontaneous means random, suddenly. Okay, spontaneous release of radiation by an unstable nucleus. Okay, spontaneous release of radiation by an unstable nucleus. If you can even remember another word, you should say spontaneous disintegration. If you can remember this word lah. But if you cannot remember this word, then never mind. You use release of radiation. Because this word is quite hard. Okay, so normally I won't recommend you to memorize this. Okay, so that's radioactive decay lah. Okay, next, right, for current Okay, current, by the way, electricity, current, I, is actually the rate of change of charge. Okay? Oh, sorry, rate of flow of charge would be better. Rate of flow of charge. Which means if I want to calculate current, I can actually use Q over T. Okay? Q means number of charge. And T is time. Okay? Rate of flow of charge. That is the meaning of current actually. Okay? Yeah, so whenever electrons start to flow, you have current. How many electrons flow every second? That is the number, that is the amount of current. So if your current is 5, that means 5 charge flow every second. Yeah, 5 charge flows every second. Okay, the unit for charge will be coulombs, C. The units for time is seconds. But the units for current is ampere. Okay? And remember, current flows from positive to negative, but electrons, which are the negative charge, flow from negative to positive. Okay? Yeah, always opposite one. Current and electron flow is always opposite one. Okay? Alright, next one. Let me just find out what is this first. Okay, this one I haven't actually taught in class. Okay, I haven't actually taught in class. It's about quantum physics one. Okay, about quantum physics, but I just tell you now first. This word is called threshold frequency. Just in case they ask you, okay? Just in case they ask you, you just remember this only lah. Okay, you just remember this. It's the minimum frequency. Minimum frequency of light required to release electrons from metal surface. Okay? Minimum frequency of light required to release electrons from a metal surface. This is called threshold frequency. Okay? Yeah? If you don't know what is it, never mind. You just remember this first, just in case they ask you. Yeah, just in case they ask you. This is for quantum physics. Quantum physics. Okay? Okay. Alright, next thing, let's talk about Bernoulli's principle again. Okay, let's talk about Bernoulli's principle again. So for Bernoulli's principle, right, remember, let's say they give you a shape that's like this. Okay? Now, if let's say this is in air, it will be called aerofoil. If let's say this is in water, it will be called hydrofoil. Okay? Air means aero, hydro means water. Okay? So the concept is like this. The part that goes, let me draw the shape better first. Okay, the concept is like this. The part that goes on top will be high velocity and low pressure. The part that goes bottom will be low velocity, high pressure. How to tell which one got higher velocity? It's because this one got further to go. This is a curve. A curve is always further than a straight line. So whoever need to travel further must be higher velocity. Okay? You always remember like that. So even if they flip it upside down, you can tell this is a curve. So this one must be higher velocity. Okay? Yeah? So even when they flip upside down, you will be able to tell. Okay? So you remember, you tell them, oh, here got high velocity, here got low pressure, here got low velocity, here got high pressure. Then you say difference in pressure causes a force. Yeah? Difference in pressure causes a force. High pressure, low pressure, you will have a force pushing up. Okay? Because there's a difference in pressure. Alright? That's Bernoulli's principle lah. Okay? Okay, another thing is elasticity. Alright? Elasticity. Okay, first of all, what's the meaning of elasticity first? Elasticity means the ability of an object to return to its original shape and size after force applied is removed. Okay, so can your object go back to the original shape and size or not? If can, that means it's elastic. If cannot, then it's not elastic. Okay? Yeah. So like a spring is elastic. So normally this question will come with F equals to kx lah. That's the formula for spring law. So this is the force. This is extension or compression. Not always extension can be compression also Okay, and this is the spring constant or the force constant. Sometimes we call force constant. Basically tell you how stiff is the thing, how hard is the thing. Okay, so that is elasticity. What else? Okay, electromagnetic induction electromagnetic induction. Okay, let's talk about wireless charger. Phone wireless charger. Okay, so let's say this is your phone. Okay, yeah, this is your phone. And then this is the wireless charger. Okay, so why can the wireless charger charge your phone? Okay, because let's say you have AC going in, alternating current. This will produce a changing magnetic field. Okay, alternating current produces a changing magnetic field. So this magnetic field will go big, small, big, small, big, small, big, small, like that. Okay? Then inside your phone there is a coil. The coil will cut the changing magnetic field. Okay? The coil will cut the changing magnetic field. So this will induce current or induce EMF. You can write both lah. You can write this will induce an EMF and current flows in the coil to charge your phone. Okay, induce current flows, induce EMF. EMF means voltage, by the way. Yeah, EMF means voltage. So this is one of the use for electromagnetic induction lah. Okay, for a wireless charger. Okay. Next we have specific heat capacity. Let's talk about that. Let's talk about specific heat capacity. Okay. So specific heat capacity, the definition is energy required, or you can say heat energy required. Heat energy required to change the temperature. Okay, change the temperature of 1 kg of substance by 1 degree Celsius. Okay, so very important, you must mention 1 kg of substance and you must mention 1 degree Celsius. How much heat energy you need, okay, for 1 kilogram of thing to increase by 1 degree or even decrease. You want to cool down something, you have to remove heat energy to decrease by 1 degree. That is also specific capacity. So if you talk about land breeze or sea breeze, remember, this is what you have to remember. Land, lower specific heat capacity. Okay, land has a lower specific heat capacity, which means that land heats up faster or cools down faster. Okay, then you say the hot air will move up. Hot air above where? It depends, because sometimes the hot air is above the land, sometimes hot air is above the sea. Okay, so you must tell them hot air above where is less dense and rise up. Okay, then cold air will move in. Cold air move in from where to where. Okay, so let me draw for you. Let's say this is land and sea. So if we say daytime, land is hot because land heats up faster because lower specific capacity. Okay, then hot air above the land will rise up. Hot air above the land is less dense and rise up. So the cold air will come in. This is called sea breeze. Because it comes from the sea, the cold air move in from the sea to the land. Okay? But at night, it's a bit different. Yeah? At night it's a bit different. Because at night, the land will cool down first. At night, the land will cool down, so the sea becomes hot. The air above the sea will be hot, so it will move up. So cold air will move in from the land. This is what we call land breeze. Okay? So always just remember, who heat up first? Who cool down first? Then you think about the hot air. The hot air goes up, someone must come in and fill up. That's the cold air. Okay? So this is specific heat capacity, and more specifically about land breeze and sea breeze. Okay? Yeah? Alright, next thing we can talk about is transistor. Okay, transistor. And maybe for transistor, right, let's talk about the automatic circuit. Yeah, the automatic circuit. So automatic circuit normally looks like this. Like that, like that, like that, like that, like that. Normally we use an NPN transistor lah. Okay, normally it will be like this, NPN. Okay, like that, like that. Battery. Okay, and then here you must have something like that, like that, like that, something. Okay. Wow, very nice drawing. Okay, then here we have something. Okay, now doesn't matter whether you are doing the light version or you are doing the heat version. Okay, so long as you remember a few things. These two are fighting for voltage. Whoever got higher voltage will get, whoever got higher resistance will get more voltage. Yeah? Whoever higher resistance gets more voltage. Then this guy, I forgot one resistor. Here. Okay, this guy will always copy this guy. This guy always copy this guy. Okay? Yeah? Who here? Here. Who high resistance, who high voltage. Okay? And then this guy always copy his voltage. Copy his voltage. Then you need to tell what happened to the base current. If the base current is low, then the collector current is low. This leg is called collector. This leg is called base. Okay? If the base current is high, collector current high. Then this one activate. Okay? So let me give you an example. I'm just going to give a simple example. Let's say we do one example with a thermistor. This is what a thermistor looks like. Okay? So thermistor, and then let's say here I put a siren. Okay, let's say this is a siren. Okay, okay, I just draw a speaker lah. Okay, so this thermistor, if temperature high, resistor low. Temperature low, resistor high. Understand? If it's LDR also light high, resistance low. Light low, resistance high. Always they do opposite one. Okay, always they do opposite. So let's say right now, hot or temperature high. Okay, let's say temperature high. Then what happened to the resistance of the thermistor? If the temperature is high, then the resistance of thermistor will be what? The resistance of thermistor. Suddenly got one Liang Jie mathematics. Yeah, the thermistor resistance will be low. Okay. Okay, so if the thermistor resistance is low, then the base voltage will be high. Let me tell you why. If this person low resistance, his voltage is low. That means the other person that's fighting for the voltage, he will get more voltage. Correct or not? He will get more voltage. And if he get more voltage, then this person will copy. This is the base. This is the base. So this base person will copy his voltage. So base voltage is high. Now when the base voltage is high, then we say the base current is also high. Okay? This guy, this thing here. Base current. And if the base current is high, then we say the collector current is high. Okay, we say the collector current is high, this guy. And if the collector current is high, then whatever here will turn on. So you say the siren will turn on. Okay, the siren will turn on. So this is what? This is a fire alarm, no? Fire alarm, when it's hot, then the siren turn on. Okay, automatically fire alarm. So you use the same idea for any automatic circuit. You just say, if this thing like that, then the voltage like that. If this voltage like that, then this voltage like that. If the base voltage like that, then the base current like that. If the base current like that, then collector current like that. If the collector current like that, then whatever turn on or turn off. Same one, always the same one. You can try this with any question. It will always work. Okay? Yeah? Alright, so that is basically all the time we have for today. Okay, so this thing, right, you all can later on, you all can come back to this video anytime. I think YouTube will post a copy of this one. So later you all can come back to this video at any time, okay? And then you all can refer back to this, you all can screenshot this down, okay? Yeah, because this is not in the PDF. Okay, so later you screenshot this down, or you study this before your exam day. Okay, right? So I hope you all have learned something today. Okay, if you have any questions, feel free to ask me. You can comment in the video, right? I will try to reply as soon as possible. You can send a message on my Instagram. Okay, my Instagram is right here, yeah, up there. Okay, you can find me on Xiaohongshu also if you know Chinese. Okay, so thanks for coming. Hope you all learned something, and yeah, you're welcome. You're welcome. And I'll see you all later on during SPM. Okay? Yeah, before SPM we're gonna do this again. Don't worry. Yeah, this is just trials only. Okay? So I'll see you all soon. Bye bye.